Hi, welcome. So we'll learn about the client types, how to create a player, how to create the logic. We know how to run an experiment, but we would like to get some data out of it. So this is how we learn how the data is saved and how we can make sense out of it. So basically there is an object called node.game.memory, which is available on the logic client type. And somewhere in one step, you need to decide what you want to save. In the most basic example, you just call the save command and you give the name of the file, in this case data.json. There are two default formats supported, JSON and CSV, comma separated values. And since the CSV format is what is most useful for the data analysis, we're going to specifically focus on that one. To launch the server first. So I'm going to play the game with a special client type called autoplay, which is similar to a bot, except it is executed on the browser, so it actually loads the interface. We will not learn how the client type autoplay is done in this video. We will just use it for the time being. You see, this is actually playing and actually testing the game. It also helps us to go through it very fast. Okay, while this is being played, we can have a look at the code to learn where the data is saved. So we are in the logic, the game is being played. We see that here at the top, we have a reference to the memory object, which is saved, taken from node.game.memory. So somewhere we're going to use this to save our data. Let's see where. So we start into the ultimatum stage, which is the stage in which the player exchange the offers for the ultimatum. What we're doing here, we are creating a view on the memory. So it means that we want to have a sub data set which contains all the items which are created into the ultimatum stage. So it is a view on the data set, and we're just using the this command to make sure that the stage is ultimatum. The view command takes two parameters, the name of the view, in this case ultimatum, or you can call it whatever you want, and the second parameter is a function. In this case it's returning true if we are in the stage ultimatum. So if it returns true, the item belongs to the ultimatum view. So going a bit down, we see a couple of things. Here we are in the exit function of a specific step. Which step is the responder step. So the ultimatum stage is composed of two steps, Peter and responder. So we are in the last step of the ultimatum stage, which is repeated for 2 rounds. So every round at the end of the stage, we want to do something which is saving the data which is created during this stage. We are saving it using the ultimatum view, which contains all the items created in the ultimatum stage across all the steps. We want to save them inside a file called ultimatum.csv. We will see where it actually goes. Since it is CSV, we want to specify a header, a custom header, otherwise it gets too messy. It takes, we want to select exactly what it contains. If we wouldn't have specified the header, it will contain more information beside what we actually need. So this is the header parameter, so this is, you need to know what data is created. So we will have a deeper look into this in a moment. What is important is that there are the options below here. So flatten equal true, it means that it will create one row with all the items that are in the ultimatum view. But we also have the other options that flatten by group equal to player, which means we'll create one row for each player, which is exactly what we want. And the last parameter says updates only equal true, which means that whenever we call the save command, we only add the new item which have been added to the database. So in round 2, it will not re-add to the file system the items which were already stored in the round 1. So to break it down a little bit more, we have the save command, which takes the file with a given extension, comma separated value, and we can specify a custom header, which is recommended. we have the two options together, which are flatten and flattened by group, which means that we want to have it one row with all the items, and then we want to split it by player. And we want to save again only the updates at every round. Let's have a look at this file already, which has been generated because the game has been played. So we are in the data folder of the Ultimatum game. So I just made it a little bigger, and you see the folder called room 00001. And you see that this room name matches the room name, which is shown here in the monitor. So we play the game, and this was assigned to room 1. Here it is. So it was an autoplay player and a bot player. This is exactly what the players which we were playing. So the content of room 1, it is saved under the game folder data room 1. If we look inside, there are several files, one of which is the ultimatum.csv file, which we just created. And you see it contains exactly the information that we wanted to save, specified in the header: session, player, stage.round, role, partner, offer, and response. Let's check whether they match. Yes. We could have actually used just round here. It would have worked. Where this information is taken from? Basically, each time we use the node.done command, for example, in this case, we send an offer message, the following item is creating on the memory object. So it contains the stage in which was it created, the player ID, which created the timestamp, the actual information we passed, here, offer 1. If it was the time up, the time, and done. As well as we will see the room name session, which is added by not game. So as you see, this is been added here, the round in which was created during the stage, the role of the player. If the stage contains a role, this is also added, and if the stage contains a partner, in this case how the player matched, this is also added, and what we wanted to add, offer and response. Let's look on the player where node.done is called. Here, for example, the response has been sent, not response, and this object here is what we see here. So the response, accepted, rejected, was the response of the responder in each of the 2 rounds. For the offer, inside there is a slightly difference because this is done in, sorry for the double done meaning, it is done in a done callback. So here we are in the done callback, which is a function which is executed after the node.done button is pressed, and we see that we don't explicitly call node.done, but instead we return a value here, which is equivalent to having the node.done message here. But we don't recall node.done because this is already invoked, for example, here in case there is a timeout. This function is executed and can modify what values are actually returned. Because this is a widget step, so it takes the value directly from the widget. If package is here, we don't want to send the whole information the widget is creating, we just want to send the offer. And we use this function, the done function, to manipulate the return value. Okay, so we've seen that we created this ultimatum.csv using these lines of code here. This is saving the file, updating the file at each round. If we go a bit below, we see there are other views which are created here. These are for the end game. So this view does not have a second parameter here after the feedback, the name of the view, which determines which items belong to this view, which means that all the items which have a feedback property will be added to this view. So in this case, we want to save again a CSV file. We give the header that we want, and we have the keep updated equal true, which means whenever some item is added to the feedback view, this will be dumped to the file system into this file. Equally, the same is applied to another view, the email, which saves to email.csv. And it has the keep updated flag equal to true. So now let's see that those files have been created as well, but they might be empty because the ultimatum autoplay is not automatically filling them up. Let's see, for example, the page here. You see, this is actually these two fields here. Now we're gonna fill something here. Sorry. I'm gonna submit, and I'm gonna also leave some feedback. Hi, this was way too easy. Oh, we want to have it at least 50 characters, so okay, then I will write a bit more, and we submit feedback. Okay, now these two messages have been sent, and this code has run, and we see hopefully Windows did not complain that the file was open. Let's close all these files, and let's check if it was updated, starting with the feedback, which was not open before. Yes, the feedback is now here. Let's check if the email worked as well. Yes, we have the test email here as well. So these two files are generated, are updated automatically whenever some data is coming in. So this is useful when you don't know exactly when the data is arriving. And these two properties, these two views with the keep updated properties have the advantage that they don't save immediately the data coming in, but that they buffer the data and they save it in a cluster, so we don't have an excess use of the CPU and of the I/O system. So it's doing it in a smart way. So we have another two files which I haven't looked here. So the bonus, or three files actually: bonus, memory all.json, and times.csv. So the bonus file, bonus.csv, contains the bonus for the players in case you have a game which supports giving bonuses to the players. In this case, the payoff for the player depends directly on their game decisions. Here they earned 1 cent and 4 cents. Not great, but also was very short game. So this is automatically generated by the compute bonus as long as we use the update win method. Here it is. So we have game room.update win, and we see who won what, in this case with the amount of coin minus the offer, and vice versa, the offer for the bidder. This is there is another feature of the memory which is sometimes useful to know. So in this case, to recover the offer from the previous stage, we use the resolve tag offer. So we can tag a specific item in the database with the tag command, and then we can recover it with direct access very fast at any other point in the game. So here we see we are in the responder step, and the role is the responder. In case in the previous stage the bidder sent a bid, and we tagged that with the tag offer, and we are recovering it here. And it's important that you validate the incoming data, so we don't directly save the incoming offer without checking this is within the valid range, and this we did above. And here we just use the update win, so we say to the game room what exactly is the payoff, and by default update win is adding to the current win of the player. You can also reset it, but we don't see that now. Okay, so the game room compute bonus will save the bonus file as well as notifying the players of what they have earned, and then it's creating the bonus.csv file which we just see here. Then we, for convenience, we want to save all the items in the database in the memory all.json file in JSON format. So this is the native format in which they are arriving. Let's have a look. This is some useful for in case there are some problems that you saved, you can always recover it here. So it was opening here. So you see, this is actually the raw data. There is a lot of information here, more than you usually need. So starting from stage 1.1.1, which we had was containing demographics information, which we added later on to it's not part of the standard Ultimatum game. Let's leave, for example, for the offer, so we can check. So this is actually the message which arrives when the player sent an offer. Contains the offer, the time that it took to create that offer, who was the time up, who did it, who was the partner, and so on and so forth. So this data is all saved here. I'm just closing it now. And the last file that we're saving here is the time to CSV. So the time to take each step. So actually, maybe I want to reopen it so I show it to you. Something which I forgot to show you. So in the memory all JSON, each item contains a time, and the time is associated with the done. The time associated with the done step. So when we're done, it's what we want to save. We want to save all this data here, all the time properties. And this we're doing this using the done view, so which is all the items which are creating with the node.done method, or through a widget step which invokes node.done. They will have the time and time up property, and we want to have this file saved. Let's have a look how it looks like. Here it is. So we have the time to create, to take a decision each step, and it was a time up. You see, in this case, the autoplay player also invokes time up sometime in the responder and bidder. So this is all from the code side. I want to show you can get the same information from the monitor interface. So if you go to the results tab, it shows you that all the files which are being created in this room are available for download in here. So it downloaded the bonus file. It is convenient most of the time to download everything in a zip archive, which you can also do it here. Here it is. It contains the whole data folder, and this is something you usually don't need to do, but in case there is a problem with the data file saved and you forgot to save something important, you can download the memory database of all game rooms using this command here. Use with caution, because it might be an intensive procedure if you have many game rooms, or if the data structure contains cycles. So this is actually what it was saved. This is exactly the same in our case of what we save with in the JSON format. This was all for the saving commands, and you know how to do everything. You know how to create a game, create the client types, and get the data out of it that you want. Now you should go and analyze it. Thank you.